Hello everybody, this is Mr. McNair, and these are the OGT questions from 2007 that had to deal with patterns, functions, and algebra. Real quick, I would suggest that you pause the video and read through these tips. Alright, problem number 2. The first 4 rows of a number array are shown below. Okay, what number will be at the far right end of row 7? So we want to know if we were to continue this array, what number will be at the far right end? Okay, so these are the numbers on the far right. Now, a couple things you should notice about this array. Going from one row to the next, and from one column to the next, you're increasing numbers by 10. 10, 20, 30, 40, 50, 60, so on and so forth. Okay, so we're increasing by 10 every time. All right. Also, you should notice that row 1 has 1 number, row 2 has 2 numbers, row 3 has 3 numbers, row 4 has 4 numbers, and so on and so forth. All right. So if we were to keep that pattern going, row 5 would have 5 numbers, row 6 would have 6 numbers, so on and so forth. So one of the non-mathematical ways, I guess you could do this problem, would be just to kind of continue this pattern. Say, okay, well, in row 5, we would have 5 numbers, and they're going to start off by starting at 110, because 110 is 10 bigger than 100. So 110, and once again we have 5 numbers. So 110, 120, 130, 140, 150. And then we can go to row 6. And that'd be 160, 170, 180, 190, 200, 210. Okay, so that's 6 numbers. 1, 2, 3, 4, 5, 6. And row 7. This will have 7 numbers. 220, 230, 240, 250, 260, 270, 280. Okay, 1, 2, 3, 4, 5, 6, 7. All right, so row 7, and that's where we wanted to know what number will be at the far right end of row 7. So here we are at row 7, and that is 280 would be the number at the far right. Okay, so that's one way to do the problem. Another way that you could have done this problem is you might have noticed a pattern here when dealing with the numbers in the far right column. All right, from here to here, we increased it by 20. From here to here, we increased by 30. Here to here, 40. So to the next one, we'll be increasing by 50. Okay, so that'd be 150, and that'd be in row 5. Row 6, we would increase by 60. So that'd be 210. Row 7, we would increase by 70. So that'd be 280. And once again, we would get 280. Okay? All right, number 7. Jamie is buying peanuts and walnuts. He wants to spend exactly $30. The graph below shows all possible ways that he can split the $30 between the peanuts and the walnuts. What does the point N on the graph represent? All right, so a couple things you should notice about the graph. The x-axis here has to deal with the money spent on peanuts. The y-axis has to deal with the money spent on walnuts. Okay, so now we're at point N here. Here's point N. So point N, if you notice, is 30 here on the y-axis. So that means we spent $30 on walnuts, and is 0 on the x-axis. So we spent all of our money, because we only had $30 to spend. We spent all of our money on walnuts. So he spent all $30 on walnuts, which is choice A. Okay? All right. Number 18. Nancy decided to breed gerbils to sell to a pet store. She started with 2 gerbils and determined that they should quadruple in number every 4 months. Nancy sold all the gerbils to the pet store. Nancy sold all of the gerbils to the pet store at the end of 1 year. How many gerbils did Nancy sell to the pet store? Well, we're talking about quadrupling every 4 months. So first thing that you want to talk about is, well, before we even do that, let me say this. Quadruple, if you notice the word quadruple, that means to multiply by 4. Quad means 4. And then we're doing that, we're quadrupling every 4 months. So in a year, okay, because we're talking about how many gerbils did she sell the pet store in 1 year. In a year, there's 12 months. So how many 4 months periods are there? Well, if there's 12 months, there's three 4 month periods. Okay, so we're going to quadruple how many times? Well, one for every time. So one for every set of months. So that's a total of 3 times that we're going to be quadrupling. So let's just say that we started off the year at the very beginning of January. So we're going to quadruple it, so we're going to multiply it by 4. And at the end of our period, the beginning of the next, we'll have 8. Then again, we'll multiply it by 4, we're quadrupling again. And at the end of that period, we'd have 32. And then again, we'll multiply by 4. And at the end of that period, we'll have 128. So there will be a total of 128 gerbils that she sold to the store. Okay, number 24. Marcy and Troy disagreed about the answers to a problem. Marcy said that the equation they were working on had more than one solution. If Marcy is correct, on which of these equations could they have been working? Now, this problem you can do a couple of ways. You could technically go through these problems and solve each of them to see which one would have more than one solution. Like, just to make sure, let's take a look at A. If you solved A, 2x plus 4 equals 3x plus 4. All right, whenever you're solving an equation, you want to get the variable isolated. You want to get it by itself. Now, this problem, this equation that we're dealing with here, the variables aren't on the same side, so it's hard to get them isolated right off the bat. What you want to do is take one of these and move it to the other side. Okay, and by side, we're talking about across the equal sign. Okay, so let's say we wanted to move this 2x over here. Well, you can't just add it. This is a positive 2x. To get rid of a positive 2x, you would subtract 2x. Whatever you do to one side, you have to do the same thing to the other. So those would cancel out. You would get 4 equals, 3x minus 2x is 1x plus 4. Then you would subtract 4 from both sides to get x by itself. The opposite of addition is subtraction. So 4 minus 4 is 0. Those would cancel out. You get x equals 0. So that would be the one answer for part A. So part A doesn't have more than one solution. It's only one thing that would work for that. All right. Now, another way that you could do this problem, we're not done obviously because we don't have an answer yet, is when they tell you that there's an equation that has more than one solution, especially a linear equation that has more than one solution, the left side of the equation and the right side should be equal to each other. All right, so I'm going to go ahead and just take these equations and I'm going to separate them left and right. Once again, an equation, the left and the right are separated through the equal sign. So if the left side equals the right side, that means that the two equations will have more than one solution. So 2x plus 4 and 3x plus 5, those don't equal each other. So it couldn't have been B. It wasn't A. 2x plus 4 and 2 times x plus 2. Well, 2 times x plus 2, if I distribute it here, I would get 2x plus 4. And 2x plus 4 equals 2x plus 4. So this is my answer. All right. Again, if you did that in D, you would get 2x plus 6 after you distribute it. And 2x plus 4 that's not the same thing as 2x plus 6. So the answer was C. That has more than one solution. All right, number 30. A construction company buys $38,400 worth of new equipment, the value of which decreases linearly so that its value after 8 years is $2,200. By what amount is the value of the equipment decreasing per year? Now, when it says that something is decreasing linearly, that means that it's decreasing at the same amount per year. Decreasing at the same amount per year. Okay? So that's what decreasing linearly means. So, what they want us to find is the amount that is decreasing per year. So, first thing that you probably would like to see is how much did it decrease? What was the total amount of decrease for the whole 8 years? So, at one point we were at $38,400 for the value of the equipment, and then we decreased down to $2,200. Okay, so how much money did we lose? How much did the value decrease? Well, we would subtract those two numbers. Okay, when you subtract those numbers, we find that it decreased for a total of 36,200 in the 8 years. All right, that's the total amount that it decreased. Now, if it's going to be about the same amount for the 8 years, we're going to take that 36,200 and divide it into 8 years. So let's see. 36,200 divided by 8 gives us 4,524. So our answer should have been 4,524. That's how much it decreased per year. Okay. All right, number 38. Mr. Richards needs to price items that must be sold within 90 days, and he has two options. In option A, Mr. Richard prices items at $225 and gives $1 off the price for every day that the item does not sell. For option B, he prices items at $250 and gives $2 off for every day the item does not sell. In your answer document, write an equation for each option that relates the price of the item to the number of days that the item has not sold. Use the equations to find the day on which the two options yield the same price. Okay, so let's look at option A. All right, this problem again, I'll probably read it through twice. All right, so you might want to pause the video and read it again. But in option A, Mr. Richards prices items at $225 and gives $1 off every single day. So an expression that relates that would be, all right, we're starting off at $225 and we're taking off $1 every day. All right, that's a D. All right. In option B, we're starting off at $250, and we're taking off, so that's subtraction, $2 every day. And we want to know when are those options going to be equal to each other. All right. First thing that I personally would do here, once again, like this problem is similar to a previous one that we did, I would first notice the variables aren't on the same side. So you need to get the variables on the same side. Okay, how do I move this minus 2d over here? Well, the opposite of minus 2d is plus 2d. So you can add 2d to both sides. So that would give you 225. We're just going to bring that straight down. Negative 1d and positive 2d add together to become a positive 1d. Or just d, you could put. And that equals 250 on this side. And the 2d and the negative 2d cancel out. All right, I'm going to move this up a little bit, hopefully. Let's see if this works. Okay, good. So now we're going to go ahead and solve for d again. Once again, our whole goal is to get d isolated, to get d by itself. What's keeping d from being alone? Well, there's 225. So how do I get rid of a positive 225? You subtract 225 from both sides. So these cancel out, leaving you with d on the left. 250 minus 225 is 25. So use the equations to find the day on which the two options yield the same price. These two options will have the same price on day 25. Okay? All right, and that's your answer. You could also take this 225 and plug it in to make sure it works. 225 minus 1 times 25. Well, 1 times 25 is 25, so that's going to be $200. And 250 minus 2 times 25. Well, 2 times 25 is 50. 250 minus 50 is 200 also. So you would also be able to tell me that on day 25, they're both going to be $200, both options. All right. Number 44, last one for this section. Jackie has a job selling cars. Her monthly salary is $2,000 plus a commission of 1% of her total sales, up to $100,000, and 1.5% of additional sales above $100,000. Which graph represents this relationship? All right, let's go ahead and go through this problem one step at a time. All right, so her monthly salary, Jackie's monthly salary is $2,000 plus a commission of 1%. All right, so let's look through our choices and see if we could eliminate any. First of all, we know that Jackie's commission or Jackie's salary is $2,000. It starts off at $2,000. So we could automatically eliminate which one? A, because this one didn't start off at $2,000. It started off at zero. All right, automatically, without anything else, she's automatically getting at least $2,000. Okay, next, we know that her monthly salary is $2,000 plus a commission of 1% of her total sales up to $100,000. So we're going to be starting at $200,000, and our graph should be increasing slightly as it gets up to 100,000. So which of these graphs isn't increasing? Okay, B isn't. B is not increasing. It's not increasing slightly as we go up to 100,000. Now, when we get to 100,000, there's going to be another increase. We're going to go up even steeper to 1.5. We started off at 1%, and then once we get to 100,000, we go up higher to 1.5%. So the only one that goes up higher after that we see is C. Okay, starts off at 2,000, increases slightly, and then it starts going up even faster. Okay, this one it tapered off. Alright, so that's not going to be the answer. Alright, great. Hopefully this video was helpful to you, and good luck studying for your OGT.